Hi there. So I guess today my name is Ben Oberkfell. I'm going to be talking to you all about fingerprint authentication on Android. So I am an Android developer at American Express. I'm on the team that builds the US card member servicing app for Android. So if you got an Amex card and you use our app to pay your bill or check your balance or check out your points, that's my team. I am the co-organizer of the GDG St. Louis, where I'm based. I'm on Twitter at BenLikesToCode. I have the slides for this talk are pinned in a tweet at the very top of my timeline. So if you're following along on the live stream, just hit up my Twitter, and you can follow along with the slides that way. And on the advice of my attorney, I should inform you that the views and opinions herein are my own and not those of my employer. So I guess our agenda today is we're going to talk about a couple different important things. Why and where you want to use fingerprint, how you want to do it, and how to design it right. Google has some guidelines about the design, so let's learn about what those are too. So with the Galaxy S6, Samsung introduced a fingerprint reader, but they used their own special Snowflake API, and it didn't get widespread acceptance until Google released an official API and a reference device like this lovely Nexus 6P. So now that we have Marshmallow, we have a way of doing this. So show of hands in the room. How many of you have a phone of Android Marshmallow that has a fingerprint reader? And keep those up. So now leave your hand up if you've written a 1-star review because the app didn't have fingerprint up. And there's no shame in doing it. I've done it myself. Or put your hand up if you've gotten reviews like these. These are real 1-star reviews. Yeah. So if you look at the Android version dashboard on the Google dev site, as of a couple weeks ago, almost 1 in 5 Android devices are running Marshmallow. And devices with fingerprint readers have been out for about a year now, if not longer. So that means implementing fingerprint is a feature that's going to have a return on your time investment at this point because you actually have an audience for it. Your customers are going to expect fingerprint interaction. And if you're in the room with me here today or watching this on the stream, you probably don't need any more convincing, but this stuff is going to be table stakes, so let's go ahead and learn how to do it. So where do we want to actually use fingerprint? Let's kind of look at a couple different scenarios why you might want to do this. One, obviously, is logging in. In lieu of a password, use your fingerprint. In our era of data breaches, it's getting more and more important to use a password that's long and complex, and that means it's a pain to type it in. So a fingerprint will save you the hassle of doing that. Another example is to protect critical user flows. So for instance, we've seen way too many stories of kids buying $100 in-app purchases. So you can use a fingerprint check to authorize critical flows that might cost the user real money. Or, for instance, like I'm in a Hilton hotel today and their app has fingerprints and also has electronic keys. So a fingerprint authentication would let me make sure that only I could go and use my e-key to get into my hotel room. And you may also want to be able to confirm a critical action like a purchase and prevent it from being replayed by an attacker. So here's really the hard part is if you have a flow in your app that's secured by a fingerprint scan, how do you communicate that to your back end and show a successful fingerprint scan? If you're Domino's Pizza and you only want to send a pizza order when a customer authorized with the fingerprint, would you trust this? Fingerprint validated, true? If the goal is to secure the user flow, probably not. That could be some rando with curl sending that across. So how do we do this? Well, I sold my house a couple weeks ago, and as you do, I signed a bazillion forms at the closing. The county recorder and the bank and my buyer all wanted to trust that it was me who signed that paperwork. So all those forms were notarized. So how do I notarize my pizza order? So to help us with that kind of line of thinking, let's look at the Android platform. So Android's open source, as you know, and anyone can go and build a device that runs the Android open source project code. But to get the Google goodies, you need to follow the compatibility definition document. And the document says that in order to get the Play Store, you got to meet these criteria. And one of those is that if your app has a device has a fingerprint reader and a developer-facing API, the CDD says you have to have a hardware-backed key store and you have to implement the API and the SDK that lets you gate usage of encryption keys based upon a fingerprint. So what does this mean? We can create, for starters, we know we can create encryption keys that can't be used without authenticating with the fingerprint reader. So that means that if we can use the key, we know we had a successful fingerprint scan. So how do we use that for authentication? So let's look at a 10,000-foot view here. We can create a public-private key pair and make that key require authentication at the fingerprint scanner to use. Then we can go ahead and register that public key with our backend and associate it with the user record going forward. And then now, anytime we want to make a critical request to our backend that relies upon the fingerprint, we can sign that with the private key that we have backed by the fingerprint reader. And finally, our backend is going to verify that signed request and either act upon it or deny it. So here's kind of the end goal. I got a sample app here that's kind of like Uber, but for baked potato delivery. We call it Tuber. So, our example here, we'll register our user's private key with the backend, and then they can go and authorize their purchases with the fingerprint. And the video is not playing. Or is it? Oh, it is. So, yeah, let's go back one here. Here we go. So, in our video here, we'll have, we authorize our fingerprint, and then we've successfully registered it with our backend. And then here now, we can go and make a purchase. We'll tap on a baked potato. We'll get a prompt for our fingerprint, and we'll get a message back from our backend saying, hey, we've got a successful order. So how do we actually do this in code? The first step is to go and create that key pair for us. So I'm going to go ahead and create a key that uses RSA encryption and a SHA-256 digest. So that's going to go ahead and digest the data we're going to sign later and then sign it with RSA. Now here's the kicker. In our parameters for the key generator, there's set user authentication required. And so that's what marks this key as being locked up behind the fingerprint reader. So then we can go and sign a request. And here's some kind of sample code for how we would sign that request. We would go ahead and create a Java signature object and then drop our private key in there and then sign the data using the signature object. But this isn't going to work right off the bat because we haven't actually authenticated the user for our with the fingerprint. And so we get a failure here, which is good. So how do we actually go ahead and do that authentication? So here's some prereqs to pay attention to. There's a use fingerprint permission you'll need to call for in your manifest. It's auto-granted, so you don't need to go ahead and use Marshmallow permissions to prompt the user. And there's a Fingerprint Manager class in the SDK from Marshmallow forward that lets you query the hardware and work with the sensor. But to make our lives easier and avoid getting a lot of angry squigglies from Android Studio, there's a Fingerprint Manager compact class that kind of levels the playing field between Marshmallow and before. So, in the instance where you're on an older device, it's just going to treat it like you don't have a fingerprint reader at all, which is kind of handy. So we can use our Fingerprint Manager and query, do we, what is hardware detected, do we have hardware? So with that, we could go and prompt our user and say, hey, great, you've got fingerprint on your phone. Would you like to use it? And then we can also go ahead and prompt, we can query whether they have fingerprints enrolled in the settings on the phone. So we could go and say, hey, great, you've got a fingerprint reader on your phone. You don't have any fingerprints enrolled. Why don't you go ahead and do that, and we'll make your life easier with our app. So let's go now to how we would use the Fingerprint Manager to do authentication. So let's kind of break this down. Here's a little bit of sample code. So the Fingerprint Manager has this class called the crypto object that kind of wraps the type of crypto operation we're going to be doing here. So, while our example here is going to focus on using asymmetric keys, public-private key signing to do our authentication, you can also use this to gate a symmetric key or, asymmetric encryption, where you actually use public-private key encryption rather than signing. But we're going to go ahead and use a signature. So since we're signing, we're going ahead and let our crypto object wrap that Java signature object we made in the the previous slide. So now we have our Fingerprint Manager authenticate call. So we're going to pass in our crypto object. There's some flags that you'll find in the SDK. There's a cancellation signal, and then you get a callback that we'll talk about in a little bit that lets you get information back from the Fingerprint Manager, what happened. And then optionally, if you want to have these callbacks posted onto a handler instead of the same thread, you can pass in a handler as well. So more on the callback in a bit. Why don't we talk about this cancellation signal? So the cancellation signal is how you tell the fingerprint reader to stop listening once you're done. So obviously in real code, outside of this, we don't want to actually have it logically scoped to this method. But what's really kind of important here is to pay attention to your activity lifecycle, because you want to stop listening for the fingerprint when you're not active. You can go ahead and end up interfering with other apps if you are still listening when you're backgrounded. So let's go back and get a look at that callback. So there's a Fingerprint Manager authentication callback that you will define, and they have a couple different scenarios that you'll get callbacks for, depending on how the fingerprint scan worked. So a successful authentication gives us an authentication result, and that wraps that crypto object that we passed in. But this time it's been blessed by the fingerprint authentication. So we could go and unpack that signature from the crypto object and then use that to sign data now that the private key's been unlocked by the fingerprint. And then one caveat here we found out in our work with this is that you can only use that crypto object once. So once you've used it, it's done for good. You got to re-authenticate. So great, we got the happy path. How do we handle unsuccessful authentication? There's a couple different scenarios here that you have to plan for. One is wrong fingerprint. So you scanned the wrong fingerprint and you have to handle for that. So here we have, I've used a finger that's not registered. So we need to display a wrong fingerprint message in our UI. So we have an authentication failed callback that allows us to go ahead and respond to when we didn't successfully get the right fingerprint. There's also a combination of hard errors and soft errors. So a soft error is an example here. Maybe the user swiped their fingerprint too quickly across the sensor. Or maybe the sensor was dirty. I guess if you dropped your phone in a puddle is when you might get this error. I've never actually seen it. I get the too fast one all the time. But here we have an example of you swipe too fast. So there's an on Authentication Help, which helps you to disambiguate soft errors and hard errors. So the framework even gives you a help string to present to the user in the UI. And in the interest of consistency between your app and other Android apps that use fingerprint, you should use what you get back from the framework, because you could well be in a situation too where later on down the line there's a new SDK or a different vendor that's passing in a different message related to their particular hardware. Another example here is a hard error. And the difference between a hard error and a soft error is that with a hard error, there's going to be no more callback since your authentication callback here. So in our case here, a hard error might be there were too many fingerprint attempts and the fingerprint reader locked out the hardware. So I believe with the standard SDK, it's after 5 attempts with the wrong fingerprint, the reader is locked out. And you actually have to go back and lock the phone and use the PIN code to get back in and reset the whole shebang. So, in this example here, we've gone ahead and we've got too many wrong tries. Now, what's important to note here is that if the user got their fingerprint locked out in another app, you're going to get this callback thrown at you right off the bat when you try and authenticate. So you have to handle this where you may not even get a chance to scan the fingerprint. If someone locked the fingerprint out in another app, you're just going to be, you're going to get a hard error right away. So again, there's an on authentication error, in your callback here that you define to go ahead and deal with this. And once again, the friendly framework gives you a message to use for what went wrong. So again, use that so that there's a consistent experience across all of your, every app on the phone. So another example here of a thing you need to plan for is key invalidation. So this is for security purposes where if I give you my phone and you add your fingerprint to it, we don't want you to have access to all the things that were locked out by the fingerprint before. And again, so if you add a new fingerprint, it's going to go ahead and invalidate all of the keys that are backed by the fingerprint reader. And the same goes if they turn off their lock screen and go back to just the swipe to unlock. It's going to go ahead and invalidate all of these keys. And you're going to find out about this when you try and create a signature with a key that's invalid. So when you try and do this, you'll need to capture this invalid key exception and present a message to the user. And usually the best way to do this is to fall back to password authentication and then go back through the registration flow. So how do we do this on the back end to make this work? So here's a really simple and contrived example. I mean, you probably want to do this differently. For instance, maybe you authenticate normally with a username and password, and then you get a session token. And so in lieu of a username and password here, you could pass in that session token instead. But the really important thing here is that when you register the public key with the back end, you need to sign that registration with your private key. So you sign the whole request. And that's important because this way you can prove ownership of that private key because you're able to validate on the back end. And obviously when you do this, you'll need to actually prompt, when you first do the registration, in order to be able to sign this message, you'll need to go through a fingerprint authentication flow to be able to prompt the user for their fingerprints, sign that initial request, send it to the back end. So in our example earlier where I showed you, you're going to go ahead at the very beginning of opening up the app, you're going to go and put your fingerprint on there and just say, hey, great, we've registered. So once we've registered our key, now we can go back to our pizza delivery order, and we can post this to our back end. So we've authenticated in our user flow. Now we've added a signature to this request, and we can go and send that up. So now we can go ahead and get our message back in our back end and validate it. So this is in the example code that's in my slide deck that's up on GitHub. And this is all in Kotlin, hooray. But the important thing here to note too is basically, we're going to go ahead and get a signature. We're going to set up to verify with the public key we pulled back from the backend's data store for that user. And then we're going to set the payload that we want to verify the signature for, and then we'll get a Boolean response, yes or no, did it verify. So we have to go ahead and convert our signature from base64 back to bytes, prime the signature with that, and then do the verification. So one thing to also pay attention to is normalizing that data. Signing can be kind of tough with JSON. Especially if your frameworks like JSON on the front end and the back end handle serialization for you. So one thing I did in the example here is I took that data and I just globbed it all together into one long string that's been concatenated with pipe characters, and then signed that. And then on the back end, normalize it the same way, and then verify the signature. Whatever you do the same thing on the client and the back end. You could go ahead and concatenate it like this. You could use a protobuf and sign it. You could base64 your JSON and post that. Whatever you do, just do the same thing on the front and the back end. Just concatenating it all, though, is like quick and easy. Another thing that's important here is how we prevent replay attacks. So if we're not careful, we could allow that same request to be posted and reposted. And next thing you know, someone has captured my signed request for a pizza delivery order to my house. They go ahead and replay it and then wait at my house for the pizza to show up. Even though I signed up my fingerprint the first time around, if you capture that request, Why can't I just replay it? So if we use what's called a nonce, for instance, maybe a timestamp in the request or any other piece of unique data that's available to us, maybe a challenge response from your back end, or some data that you can use to verify that you're not playing this back again. So for instance, maybe a timestamp in the request. I might go ahead and when I post my request, I'll include the local timestamp. And then if it's been more than 10 seconds since that request is made, then we reject it. If I were to go ahead and tamper with the timestamp, that would break the signature. So that message just can't be used ever again. So it's important when you're using these to, in addition to sign it, go ahead and prevent your replays. So now let's talk design and how we make this look good. So the Google Material Guidelines page has some discussion about how to design for fingerprint auth. Now, when you've seen these dialogues in your various apps that you use with Fingerprint, it all looks kind of like a system dialog, just kind of like, Marshmallow, when you request a permission in Marshmallow, you get a system dialog that is consistent across the board. The dialog from the fingerprint reader typically looks fairly consistent too, like it came from the system, but it's not. You've got to go ahead and design that yourself as a dialog fragment or however you want to do it. So the Material Guidelines page has some discussion about how to do this and how to design it right. They give you a great little red line here about how to design the dialog and lay it out right. So the header here should indicate what you're trying to do with the fingerprint. Maybe you're going to try and sign in, or you're going to make a purchase, or you're going to enroll your fingerprint with the back end for the first time around. And you should go ahead and confirm, use the phrase confirm fingerprint. That's something that they specify in the guidelines. So don't say scan fingerprint or touch sensor or anything like that. You want a consistent experience across the board. And then again, you should use the material fingerprint icon. So when you go into the settings and register a fingerprint, it presents this fingerprint icon here and tells the user, whenever you see this icon, you can use fingerprint. So if you're not using that icon, you're not providing a consistent experience to your customers. If you redesign, you'll want to keep that icon. So, here's an example from the Target app. They go ahead and use a different color scheme, but they're still using the same icon and, a different font and everything else, but they still have a similar bit of text here like confirm fingerprints, and it's a similar looking system dialog. So if you retheme your app, you'll really want to make sure that you use that same icon and help give hints to your user that you're doing things consistently. So I have an example app here. It's also on the GitHub page for my pinned at the top of my Twitter, Ben Likes Code. And what you'll find in the example app here is an example backend written in Spring Boot that's just a really simple set of a couple different REST APIs for registering a fingerprint and doing the verification. And then the example app here has an example of how to scan a fingerprint, how to get a response and post that to the back end, and then how to handle some of these error conditions like soft error, hard error, etc. A couple caveats that we had found while doing this. Again, you'll want to make sure that you use Fingerprint Manager Compat. It's going to make your life a ton easier. The Android fingerprint samples on Google's GitHub do not use the Compat library. They target Marshmallow as the minimum SDK. So you don't run into these issues that you would run if you're actually designing for lower OS versions. So definitely use the Compat. One thing I found, there's a bug in the Android emulator for the M. It's fixed in N, but not in M, where if you reboot the emulator, it will forget that there are fingerprints enrolled. So the Fingerprint Manager will respond, yes, that you do have fingerprints enrolled, but you'll get an exception back from the system when you actually try and use it because it gets out of sync. So if you run into this, it's a bug in the emulator and not a issue with your code. When you reboot the emulator, you'll have to end up going back in and adding a new fingerprint to get things back in line. And again, it's been fixed in the N image, so if you only render this if you're actually specifically running a Marshmallow AVD emulator. Another thing we'd found was that when you use when you have your authentication callback from a successful authentication, we had to actually go back and post that when you get the successful message with the crypto object, we actually had to post that back to the main thread for it to work properly. So an option there is to you go ahead and use the handler that you get and attach that so it runs on the main thread, or however you want to go ahead and do that. But that was one thing we had found out. And with that, I will open the floor for any questions that you might have. Yes.
The messages that are returned from the system, are they internationalization? Are they handle internationalization? Did you try? Did you check?
I have not done that. I've only focused on English only since this it was work on a U.S. app. So since it comes from the system, I would imagine it's going to be localized to your system language, but don't hold me to that. And then one thing that is that does come into play there, if it doesn't, is you do get an integer value back in there as well. So there are some int constants in the Fingerprint Manager that map to these error conditions like sensor too dirty or whatever else. So if for some particular reason you do want to avoid what's going on in the you get back from the system, you can still key off these integers and do that. I mean, obviously they don't recommend it, but it's there in case you don't want to go ahead and do string matching on the help text. You can actually use these constants instead. Yes.
Is it flow can use a shared secret instead of a key pair?
I'm sorry?
Can you use a shared secret instead of a key pair?
Yeah, you can. So you could use, you could use I guess you have options for a symmetric encryption key, or you can use a key pair for signing. So what you could do, I guess, is use a symmetric key to encrypt that shared secret, and then unlock it when you scan the fingerprint.
You were saying that the crypto object itself, you can only use that once?
Right. So it's been. Yeah, so it's basically the crypto object ends up getting blessed by the framework. So once you've used that key, it's put back into the not authenticated state. Okay. So you would need to re-authenticate again to be able to use that key again. So it's kind of a one-shot thing where if you can't use it to sign multiple things in a row with the same signature.
So basically each time you use it, you send it out, then you have to scan it. If you want to do 3 things at once.
Yeah, you'd have to scan. Yeah, right. Or bind them all up into one request and then sign the whole shebang. Okay. Yeah. Yep. Yes.
I noticed the crypto object is optional. Where if you just pass no in it, and if I'm just implementing it and something like app lock, right? I'm not signing anything. I just want a user to authenticate before they can get into my app.
Yeah.
Is that secure?
I guess if you don't really care, you could use the callback, and then just key upon whether or not you have a fingerprint registered. So if you're not actually sending anything to your back end, that's an option.